Hi class. Okay, we are on lesson 54. This lesson might go a few minutes longer. It has two different concepts they want me to go over. The first one is not really a review, so it's a little bit of new material, so I want to make sure you understand it. Be sure to watch it twice if it's a little fuzzy the first time. Okay, so in this lesson they want to talk to you about ratios and proportions. What is a ratio? Okay. A ratio is a fraction. It's just a fraction, and a fraction is a ratio. A ratio is basically a comparison of two numbers. So let's think of it this way. If we read this, we can read this 4/5. Another way to read that is 4 out of 5, 4 out of 5, or 4 per 5. Those are two other ways you can read the fraction 4/5. Or the ratio 4/5. Let's give it some meaning. Let's say we're trying to take a tally of how many kids in the class have brown hair, and you might take a poll, or you might take a survey and find out that 4 out of every 5 students have brown hair. So for every 5 students, 4 have brown hair. Okay, that's the manner in which we would compare the two numbers. We're trying to see how many have brown hair out of a whole group, okay? But it's still called fraction or ratio, right? For any given ratio, and we're still using the ratio 4/5, there are a lot of equivalent ratios, all right? Like 8/10, like 16/20, like 32/40, or how about 40/50? All of those represent the same amounts. They're equivalent fractions. 4/5 would be considered the reduced fraction for these other fractions. It would be the most simplified fraction, but we can still call them equivalent fractions. So 4/5 really is equal to 8/10, and that is a true statement. When we set two fractions equal to one another, we can call that a proportion. We say that they're proportional. Proportion. Okay, so this is a true statement. 4/5 for every 5 students, 4 have brown hair. So it would also be true to say that for every 10 students, 8 have brown hair, and that is a true statement. Those are equivalent. When we have one of the numbers missing and it's replaced with a variable, I'll make it x to stand out, we call this a conditional proportion, and it's something we can solve. It's a math problem now. And the way we solve that, you may have heard of this before, is called cross multiplying. At least that's one way we can do it. In a true proportion, when we crisscross denominators and numerators, they should be equal. So for example, if I were to multiply 4 and 10, I would have gotten 40. And if I were to multiply 8 and 5, I would get 40. We can see they're equal. So using that information, we can come to our proportion with the missing number, and we can multiply 4 by 10 and get 40, and we can multiply 5 by x. I probably should have written that. I'm going to write it like the algebra equations we're used to seeing. I'm going to put the 5x on the left. Now this is something we can solve. It's an algebra equation. Now you'll recognize this. How do we solve 5x equals 40 and solve for x? Well, we use our division rule for equations, and I divide both sides by 5. I would cancel these. I would end up with, I'm going to put an arrow there, x alone on the left-hand side equals 40 divided by 5, and that's 8. And we ended up with 8. And we could see from this proportion up here that that was indeed the correct answer. Okay. So in this lesson, they want to get you accustomed to the idea of cross-multiplying. So they're going to give you they're going to go right to the conditional proportions and give you one and ask you to solve it. I'll do it one more time. I'll make one up. Let's see, 7/8 equals x over 32. You can see that's going to come out evenly. All right, so how would you solve this? You would take your numerator and denominator that involves the variable, that's 8x, and you would set it equal to the other numerator and denominator. I had to make a big number, didn't I? Okay. Now I have a standard algebra equation. I need x all by itself. I'm going to divide both sides by 8. That allows me to cancel those 8's. So I now have x equals, what is 224 divided by 8? I'll go ahead and do long division. Goes in 2 times 64. 8 goes into 64. 8 times comes out to an even 28. X is 28. And that's all you do there for your cross multiplication. Let me double check the practice. Yep, that's all you're going to have to do there. So as long as you understand the concept of cross multiplying to solve for x, and then remember how to solve your standard algebra equation of 8x equals 24 or 5x equals 40, you'll be good. All right. I don't want to clear the canvas, sorry. The second concept in this lesson is, well, I always say everything's easy, don't I? But I do think it's easy. I don't think it's above you guys at all. I think all of you guys can excel at this if you want to. All right, so next we're going to talk about exponents and radicals with 2 variables. So if you remember, we call something that looks like this. That's an exponent. 3 is an exponent, and we solve this. Pay attention now. It is not 5 times 3. It is 5 times 5 times 5. Hear ye. 5 times 5 times 5. That's 125. Please do not multiply 5 and 3. That is incorrect. Okay? So just a review on exponents. Radicals. All right? Let's use the same one, the same numbers, and we'll say the cube root of 125. What is that? What does this mean? It means what number multiplied by itself 3 times, this many times, equals 125. Okay, once again, what number multiplied by itself 3 times equals 125? So this is what you're trying to find out. What number multiplied by itself 3 times equals 125? Does that look familiar? Does that look familiar? We can see the number's 5, okay? Right? We just did it. I just want you to know, I just want you to be, to understand how to work these problems. So the cube root of 125 equals 5. 5 cubed is 125. Okay, so some of the problems you had in the past may have looked like this. They might have said p squared where p equals 5. And so you would have had to take the 5, put it in for p, and solve it. And that would be 5 times 5, and that's just 25. But in this lesson, they're going to have 2 variables, and you'll have to put 2 numbers in for both variables. Let me give you an example. They'll say p to the q, where p equals 2 and q equals 3. All you do is put 2 in where p is and put 3 in where q is. Now you have the problem 2 to the 3rd power. It's not 2 times 3, it's 2 times 2 times 2. That's 8. Some of you are still getting this wrong. 2 to the 3rd power is 2 times 2 times 2. All right, so I'll do one of the radicals with 2 variables. I think you get the idea. So they might give you something like the q root of p, where p equals 1,000 and q might equal 10. So just put those in. Let's write it again. The 10th root of 1,000. Did I say that correctly? I think I meant to put cube root. I'm sorry. I don't think that's an even number, the 10th root of 1,000. Let's make that 3. That's better. They're going to give you easy problems to work out. They're not going to give you something that ends up being a decimal. Okay, so take your P and put it in here under the radical sign. Take your Q and put it there as the index. It's called the index. So this asks, what is the cube root of 1,000? What number multiplied by itself 3 times equals 1,000? Any of you guys know? We've done this before. Okay, it's 10 times 10 times 10 is 1,000. So your answer would be, look like this. That equals 10. Okay. I don't know if I need to review that again. Let me see. I just worry because I get a little sloppy when I'm writing. I want to make sure it doesn't get confusing. Okay. As long as you understand exponents and radicals, and I think some of you might still be a little blurry, you'll be fine. All right, P to the Q, where P equals 4 and Q equals 2. What is that? Let's put 4 in for P. Let's put 2 in for Q. What is that? It's 4 times 4. Sorry, that's times. Equals 16. And that's it. That's all you do in the second part. How about let's see, where P equals 27 and Q again is 3. So what you'll do is you'll just rewrite this. And you'll ask yourself, what number multiplied by itself 3 times is 27? Do you guys remember? Whoops. It's 3. 3 times 3 times 3 is 27. So you'll write this like this. The cube root of 27 equals 3, and that would be your answer. Okay? I think you guys got it. All right, signing off.